welcome to Module 8. In this module, we'll explore the solar system and its basic components. The most likely mechanism for our solar system formation is that our sun and planets slowly condense to their present form from collapsing, rotating nebula clouds of gas and dust.
This is called the nebula.
The solar nebula hypothesis is the basis of modern theory of planet formation.
The theory is that the early universe was much busier with many more objects. They collided with one another. There were lots of collisions. And as an example of that, our moon is pot-marked with thousands of impact craters that have occurred in the distant past, not in recorded human history. Sorry about this, folks. We'll make another one.
The inner planets are mostly rock. The outer planets are mostly liquefied gas. It took Apollo 11 3 days to reach the moon. At the same speed, it would take 3 years to reach the sun. This is a montage of the planets in our solar system presented in correct relative sizes. Recall that planets only shine because they reflect the light of our sun. This image provides you with a dimensional scale of our solar system. If we were to reduce all bodies in the solar system so that the Earth has a diameter of 0.3 millimeters, this is the relative size of the planets. The solar system of our childhood consists of 9 planets. The planet order from the Sun outward is Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and Pluto. We also have the satellites of the planets, which are known as moons. A good mnemonic device to remember the order of the planets is the following sentence. My very educated mother just served us 9 pizzas. The modern 21st century definition of the major planets was decided by a committee of astrophysicists on August 24, 2006, at the end of a conference meeting. Review the following image to learn about planetary orbits.
Although the planet's orbits are elliptical, they are very close to circles, and this image is pointing out the slight variations.
Planets of our solar system can be divided into 2 very different kinds. They are terrestrial and Jovian.
The terrestrial are the inner planets, and the jovial are the outer planets. The jovial planets are all gas. Saturn and Jupiter are gas, unlike the Earth and Mercury, which are solid rock balls. Remember also, this is a distinction between planets and stars. Planets do not emit their own light. Only stars, through thermonuclear fusion, emit light or radiation. Saturn and Jupiter shine only because sunlight is reflected off of those gas ball surfaces. They do not have an internal power source. The definition of planets.
The terrestrial planets are the 4 inner planets of the solar system.
And again, as I said, they're characterized by the fact that they are rocky objects, non-light emitting. They're rocky objects.
The Jovian planets are much larger in mass and size than the terrestrial planets.
What we have here in the case of accretion, the gas and the molecules have collided and formed big balls of gas, much bigger than planet Earth, but they're still not big enough to conduct thermonuclear fusion in their cores. So these are just dead balls of gas. They never grew large enough to become stars.
19 natural satellites are large enough to be round, and one, Saturn's Titan, has a substantial atmosphere. Recently, Saturn's moon Enceladus has been determined to contain a sea larger than Lake Superior. Jupiter's Io is highly volcanic and active. Minor debris from the formation of the solar system still exists. Between the orbits of Mars and Jupiter are millions of asteroids.
Notice that this small rock
In this image, you can see the
is
asteroid belt.
spotted.
These are bodies composed mostly of rock and metal, and typically just slightly larger than half a mile across. The main asteroid belt extends from 2.15 to 3.3 astronomical units from the Sun. It is between Mars and Jupiter, and may contain over 1 million objects bigger than half a mile across. The largest of these objects being Ceres, Pallas, and Vesta. This is an image of the rocky asteroid Ida and its satellite. The 34-mile-long rocky asteroid is shown here with its satellite Dactyl, which is about twice the size of the younger asteroid Gaspra we saw earlier. Note that the enlarged image of Dactyl also shows it is heavily cratered. Review the following information to learn more about meteoroids.
In addition to the asteroids, we have meteoroids, which are pieces of rock and metallic debris that come in and out the solar system, but most are in the asteroid belt. There's no distinction among sizes.
This is the Barringer crater in Arizona. An iron meteor 50 yards across struck the ground 50,000 years ago, traveling at 25,000 miles per hour, resulting in this beautiful symmetric impact crater. It measures about 1 mile wide and is 650 stories deep. This animation illustrates the origin of asteroids and meteorites.
No, it doesn't. We're moving on.
Beyond the orbit of Neptune lies hundreds of millions of chunks of rock and ice called comets, or more accurately, comet nuclei. Ionization is the name of the process by which electrons are electrically stripped from an atom in formation of the comet's tail. Comets also abound in the millions from an even farther out region in the solar system, in a donut-shaped region beyond the orbit of Pluto called the Kuiper Belt. The classical Kuiper Belt of comets spreads from Pluto out 50 astronomical units from the Sun. Most of the 200 million belt comets are believed to orbit in or near the plane of the ecliptic. Even more fantastic, the spherical Oort comet cloud extends from beyond the Kuiper Belt, beyond the orbit of Pluto, 40 astronomical units from the Sun, but it is still part of our solar system. Comets are believed to originate in the Oort cloud, spherical clouds of several trillion icy bodies between 10,000 and 100,000 astronomical units from the Sun. The solar system contains heavy elements formed from an earlier generation of stars. The most common elements in the universe are hydrogen and helium, with small amounts of heavier elements.
This is a very critical point. Hydrogen and helium account for 98% of the mass of the universe. That means the universe is mostly made up of gas. Lots of gas. But there is this little local problem.
Theoretically, all of the hydrogen in the universe was formed in the Big Bang, at the very beginning of the universe. Gravity, rotation, and heat are thought to be main factors shaping the early solar system. Accretion is the gradual accumulation of solid particles by gravity and collision into larger, solid astronomical objects. Strong evidence for the existence of planetary systems in the process of formation around other stars comes from periodic wobbling of the positions and spectral line displacements of several nearby stars. What has not yet been seen are any faint pinpoints of light slowly circling a star. However, our galaxy changed again in July 2006, when the Hubble Space Telescope revealed the first visible light image of a planet orbiting another star.
So in this module, we've learned a little bit about the structure of the solar system, the distinction between terrestrial and Jovian planets, namely the inner planets are rocky, the outer planets are gas. No planets are self-luminous. Only stars shine of their own accord. And then we looked at asteroids, meteoroids, comets, and collision and the accretion theory.